Okay, why we need a database management system in practice. Okay, so we're not just looking at a bookish definition. This is the database management system. We want to practically understand what a database management system means and how it is different from a file systems that are provided on top of the operating systems. Okay, right? That is the way we are actually doing that. Even that simple concept, when I'm starting with this simple concept of what is a database management system and why do we need it, I'm trying to build this concept for you from the point of view of there is file systems which are part of the operating system. So normally you write programs using file systems. Why that is not adequate? Why you need something like a database management system in the first place for developing your applications like the banking applications? Why an operating system, uh, file systems along with operating systems are not good enough for you to develop your applications? That's what we are trying to sort of give you the practical sense of things. We are not interested in just trying to have a slide here and a PPT slide which says database management system this, and if a question is asked in the exam paper, what is a database management system? We're not looking at whether you have exactly reproduced the definition as given in CJ date or in some other textbook. What we are trying to find out when we're doing this course here, we're trying to find out, do you understand what is a database management system in the first place? Do you understand that concept? Do you appreciate that concept? That's what we are trying to do in this course. This is very important for me because when you look at file systems, certain things are done in file system. The way an operating system deals with files, the way the database management system handles the internal data storage part, there are critical differences. We want to build those ideas as we go deeper and deeper. We will build more deeper ideas from the system side. Why we need database management system? What is the performance issues with database management systems? All this is what we would like to build. That's the reason why this course is being built in a completely different way compared to the way you would have traditionally seen people teaching this course in your college. Not teaching the course from the traditional point of view. We are not actually trying to do a bookish course. Take a book and then just do the course from the textbook. We are trying to build the practical base plus the conceptual base, both together as part of the course. I want to make this very clear because when I was started talking to people, I know they're not programming enough. Computer science is about programming, enjoying the programming part. If you're not doing enough programming, dealing with the systems, understanding the deeper concepts of the systems, when you step out of the college and get into the industry, you may not find yourself completely equipped with all the required knowledge to be able to be happy and career, lifelong career as a computer scientist in the industry. That's the reason why this course we are trying to do in a completely different way. What I have done is for today's class, as I start now going, no, the initial classes I'm trying to bridge. That's how I went to Vijayanagaram College and then started talking to them. The idea is to find out for me what the students are doing, what is their appreciation and all that stuff. And also two other colleges that I went in the last class. Okay. Um, I have my misgivings on how much people are able to really, do programming in these colleges. So what I did for today's class is, I said I will get to the writing a program, trying to show you how the same program will be different if I'm using a database management system. That's what I wanted to do in this particular class. Then I will also build how my whole using that. Probably I'm actually at 2:25, so I have about an hour, 10 minutes before I have another this thing also. So I will try to cover that part and then re-emphasize that part. The initial conceptual basis is very, very important for you before we build the bigger concepts like transaction processing, database design, all those will require much greater, foundation in the beginning and understanding the initial parts quite well. Okay. So given that, let me do, I think I will sort of, uh, you know, I will sort of do, just give me a minute. I'm just trying to, bring up my system here. Okay. Hopefully it will be up in a minute. Yeah, this is up in a minute. I also need a terminal for myself before I actually go off. As you can see, it's much um, simpler for us to actually do some of it. Okay, let me just let me share the whiteboard desktop now. Start sharing the desktop. I hope the desktop is visible now. Okay, right. See, and I'm actually doing a secured, as you can see, this is an operating system and this is a shell command on the part of the operating system. Now, operating system is the basic system on top of the hardware. This is the program that actually boots up and this is the shell that you're getting. So operating system itself is a program running on top of the bare hardware. Okay. Now, any machine where you log in, for example, here this is a secure shell command. You can log into another machine by using this secure shell command. Okay, called SSH. This is an operating system command. On top of the operating system, you have lots of system call interface. These are all commands on top of the operating system. Okay, operating system program is providing you this command called the secured shell command. So when you're executing this, you log into another machine. Okay, here I'm trying to log into another machine in my lab with with username as DJ Ram, and this is the machine IP address 10.6.9.68. Then I actually need to give the password. This is the authentication mechanism for logging into the operating system with a user ID and a password. Okay, now I'm actually at the operating system level. I'm actually logged in now into this system in my this thing, and here whatever files that I've actually stored, there are lots of files you can see. Okay, now if I want to create a directory here, make dev, okay, Jntuk Moocs. This is a directory that I'm creating. Okay, now this is the command for creating the directory. These are all file system commands. This is the directory that I have created. Okay. Now if I want to actually move, for example, okay, move or copy, for example, okay, bank master program or something like, okay, .c, which I had written for the purpose of this class, okay, to actually Jntuk Moocs, I can use this command for doing this. So it's actually now gone to this directory here. I can check whether this is there in this directory. You can see this program is in this directory. Now this is a file that I have created. No, this is a simple file in the operating system that was created. Now, if I want to read the contents of this file, what is there in this file, I use this more command. Again, this is a file system command on top of the operating system. Okay. Now, if you say here program.c, this will display the C program that I have written for this particular thing. Okay. Right. Now you can see this is how the file commands. For ls will list the directory, whatever is there in the programs that are there. If you give ls minus l, this gives the full form, lengthy form of the full. For example, this is the user ID, as I was telling. These are the permissions for reading, writing the file. These are the initial set of permissions. This is the user. This is the group. This is the others permission. This read write means the group has the owner of this file is DJ Ram. I have created it. I have these permissions, read write permissions. Okay. If the set user bit, the first bit is on, it will mean something else. We will not get into that as part of this course at all. Okay. Now this is created on July 22nd. This is the timestamp when it is created. Okay. And this is the program. So where is this file? This file is in the disk. It is created on the disk. This machine has a disk, hard disk. If you understand the hard disk, this is basically machine connected, machine having its hard disk, which is not the temporary storage, volatile memory. What is the volatile memory? The RAM part of it, where if I'm running this program, it will have its memory in the volatile part of the system. RAM part. Okay, RAM. In the RAM, the program would have been loaded into the RAM memory. Okay, and then that's called the volatile memory. That will go off when you actually finish running the program and the operating system releases that memory. Whereas the hard disk is non-volatile memory. It stays permanently. Okay. Right. So this file which you are seeing as a bank master program.c will survive. If I log out, if I power off this machine, still the contents of this will be available in the hard disk. So all this information that you're seeing about this program is available in the hard disk. Okay. This is a C program that I had written now. Now let us understand the simple case of the case that I'm going to illustrate for you why database management systems are required is a case where I will say that look at your ATM program. You will write your ATM program using C language and the files, operating system files. These are all the operating system files. Okay. Now what you're going to do is you will write your ATM program, bank ATM program using C language and the operating system files as I just shown you here. How does this program will look like now? Something like this. Okay. It has to be a lot more complete, but then, for example, if you want to edit this program, then you have to use an editor program for actually doing the program that I had created. But only thing is, it will start using the files. For example, look at here, the standard, I'm including the standard io.h. Okay, as you know, I'm assuming that you know the C program. This is this includes all the library things that are needed for you to do the standard input output for this program. Okay, all the required interface for the standard input output is part of this library that is included here. So you include for this program, first thing that you're including is the standard file system user interface that is actually called the standard input output.h. Okay. Now you have the main programs. What I'm trying to do is, as part of this program, very simple program. What I'll do now is input the customer name, his bank balance, and store it into a file. This is like saying now I have a program that actually reads the customer name and his balance and stores it into a file for me. That becomes the bank master for me. Now the minute I want to actually withdraw something, I will read from this file, debit the amount and write the balance back into the file again. Okay. So what I need is the integer balance will store the balance, N is the number of customers. So what I'm doing is enter the number of customers. I will give this number of customers here. Then I'll open a file. This is the most important thing for you. When normally speaking, C program with files, you need to actually open a FTPR, which is a file pointer. This is a pointer to a file. Okay. Now, using the fopen, as you can see here, this is the fopen command. This is the file open command, which is now a function that is written. All this will be part of this standard stdio.h, the set of libraries that are all provided for you for working with the underneath file system. So an fopen will return an open pointer. In fact, we can go further deep. This actually sets apart some buffer into which the contents of the actual file on the hard disk are read into the main memory. Okay, and this pointer will keep incrementing as you start reading or writing onto the file, onto the which is on the hard disk. Now there are several things that can be there: layers of storage, layers of programs that will all be involved in reading or writing from a particular file. All that is abstracted for you. This is only a simple file pointer, and this fopen is actually giving you a way of opening that particular file. Now this is my home directory. Since now I've actually created this directory, I'll try to create this bank master file. This is where I'm writing all the contents of the file, particular bank master. And A says append, and this program can only read the contents of this file. A write mode means that it can write the contents of this into the hard disk. Okay. Now, if this pointer is null, then you say it is error. Then for a particular set of I want to whatever that number, read the customer name, enter the balance, and then put this name and balance onto the file and close the pointer and return 0, which means that this program will create a file called bank master, write the name of the account holder and balance onto the file. Okay, that's what it will do. Okay, now this is how you would have written your programs. For example, now I can compile this program. GCC is the compiler, so basically I can compile this program. Okay, there is a slight warning. Let us ignore about the warning at this point of time and then run this program. Okay, what it should do for us now, enter the number of customers. So we'll say 3 here. Then for customer 1, enter name. Okay, we are given earlier Prashant. Okay, I am just going the same way as I had given Prashant. Enter the balance. We'll say his is 2000. Okay, now enter customer. I think we said Ramya. Okay, then we will give Ramya. Then we'll say enter balance. She has a 3000 rupees balance. Then I think we said Prabhakar. Okay, then let us say he has 5000 or 1000 rupees in his balance. So I'd given all this. Now what should happen? It should go and then write all of this into the, let us see if it has created the file. Okay, now you can see it has created a bank master. So the contents of this file can be now read by just saying bank master. So it's giving now, this bank master is giving, name is Prashant, balance is 2000, name is Ramya, balance is 3000, name is Prabhakar, balance is 1000 rupees. Okay, so this is how you can, where is this program bank master now? The bank master is in the hard disk. Okay, and this program has opened a file on the hard disk now, written all the contents into this bank master. Now you can write another program for reading from this bank master, debiting or crediting. All of that can be done using this. This is a power and storage. If you look at when I ran this program, I gave number of customers. Where is that stored? The value of n is in the volatile memory, main memory. Once this program finished execution, that n is permanently gone. It is in the main memory. It is not in the, for example, I have not written here number of customers, how many customers are there, I have not written onto the bank master. So that information is gone. That information is there only during the program execution. It is there only in the volatile memory. Okay. Now, when we are dealing with data, we are trying to use programs and write the data into the files, operating system files. Okay. Why this is not enough? Actually, I will remove this. Again, you can. These are all commands with which you are using the operating system files. I've just removed this bank master. Okay. Now imagine the kind of problem that we are talking about. Okay. Um, what happens if two people start working with the same program? Okay. Um, I guess I need to expand this one. Okay. I will log into the machine again. Okay. Okay, so Jntuk Moocs. Okay, this is the directory where I am. Okay. Now I actually have two terminals here. Okay. I think hopefully I can actually move it a little bit and show you both at the same time. Okay. Now let us say this actually runs a dot out. Okay, I run the program here a dot out. Okay, this is like I'm on one ATM terminal and trying to do this. Okay. Now look at this here. If I actually have another program also running simultaneously at the same time, a dot out. Okay, right. Now you can start seeing some one place is saying enter number of customers, the other program is also saying enter number of customers. If I say 3 here, this will go for 3 times. If I go 1 here, it will go for 1 time. Okay, right. Now you can see the simultaneous running of these programs. Okay, now causes problem for me because one is trying to say the number of customers is 1, the other is trying to say there are actually 3. Now since you opened it in an append mode, file is open in append mode, this will not create much of a problem because the 3 will get written, the 1 will also be get written, so it will become 4, the number of people who are actually entered. For example, if you say here Ramya and then say that 1000 rupees and then you say Prabhakar 2000 and then you say for Shiva you say 5000, is fine. This actually goes off. Now if you say here Janaki Ram and then you say that I have 9000 or maybe 500 rupees, then it will just go. Now if you go and look at this program Bank Master, it actually will has written all the, since it's an append mode, the file actually the contents got added one after the other, so you got all the 4 values into the file. Okay, right. If you had just put it in a write mode, then one of the values would have been overwritten, whichever is trying to write one after the other, this program would have gotten into some trouble. This is what we mean by consistency. When multiple programs are running at the same time, how the same file, both of them are actually operating on the same bank master. Okay. This is only on a single file, both programs, a dot out programs are working. This is one ATM terminal, this is another ATM terminal. Okay, when both of them are operating on the same program, what is going to happen is not, no, there is no consistency that is guaranteed by the operating system. Operating system doesn't really, it expects you only one program to file. It doesn't expect 2 programs to open the file. Okay. Similarly, it doesn't, when the power goes, it doesn't actually store the previous, it doesn't keep logs, what this program is doing, what this program is doing, in terms of keeping some logs and making sure the program is always brought to a consistent position. That means what was the condition of the file before the power went off, and what are still pending things that need to be done on the file. This is actually called the undo and the redo. That is not part of the file system that we have. This is what we are actually saying in the last class. What we are saying is critical business applications cannot be developed using C programs and files. There's much more that is required. We will see what are all the things when we go deeper. We're going to look at what are all the things that will be needed when we are doing this. One other important thing that we were talking in the last class is this format, the way the file information is written is part of the program. The file itself doesn't have any data model. The program creates the data and stores it the way it wants to store. For example, go to this bank program, bank master program, right? Okay, so let us change the format this file is being written. Okay, fprintf, this is where it is getting written. Now every things here, then you start seeing that everything will come in one line as far as this program is concerned. So the program is created the, okay, right. So let us try to run this program. Say again 3 and say now this time you say Jankiram and you say balance 300 rupees. Krishna, say 400 rupees, and you say Bhavani 200 rupees. Okay, something like this. Now look at what the bank master would have done here. Okay, now you can see this is actually in an append mode. Okay, all this were actually added later. Okay, now you can see name Janikaram balance 300. That's the first line that is written. Name Krishna balance 400. Name Bhavani balance 200. So everything, the earlier format is this for writing onto the file. The later format is this. File itself doesn't have any format for storing. It is created by the program that is writing onto this file. You can write it like this, you can write it like this, you can write in any other fashion you are actually wanting to write the data onto this file. The file itself doesn't have any data model. The data model is part of the program. This is another very important thing that we were discussing in the last class. That is precisely the reason why we want to move into a database management system. The database management system is a program on top of the operating system. Okay, it is written now providing all these requirements for you for developing a database application are all put as part of the database management system. That itself is a program. For example, we are actually seeing in the last class. Okay, now look at this. This is same as the operating system. I'm on the top of the operating system. Now ls, all these are operating system commands. Okay, these are all dealing with files. Now instead of dealing with files, I want to deal with database management system, which has inherently a data model. Okay, and then which has no, which can provide me the flexibility of two programs simultaneously opening the data, and also when power goes off, making sure the data is in some previous consistent form, and I know the logs which have still not been applied on that data. So the data can always be whatever happens, power goes off and any other thing happens, I know how exactly to restore the consistency of my data. Okay, that is it. That is what I am now. I don't want to work with files because files, operating system files, don't have these properties. So I want to actually have a database management system. Now that is what we mean by MySQL. This is a program, this is a database management program. Instead of working with files now, you will be working with a database management system. Okay. Now this management system, like the operating system, will provide you with a user ID and password. Okay. Now this is what the password is. So if you enter, then you will get, now you are into database management system. Understand, this MySQL here is the database management system. Okay, it comes with a particular data model. Okay, yeah, yeah. Mm, 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 mm. Yeah, okay. This comes with data model. That's what we are talking about. This here you can only, like what I've created as a directory here, I can create directories and tables here. Nothing else I can create. So this is basically called a relational database management system. This program only supports tables. That means I can create tables. I can create a database. I can create a no. I can create a tables, and I can insert rows into those tables, and then I can actually retrieve the information from that particular tables. Adi Madhavan, and we can do only that here as part of the MySQL here. So this is basically called, since it supports only tables, the data model that is supported inside is only tables, relations, in other words relations, which we will study in mathematical sense later. This is actually called a relational database management system. For example, you can also have a different program called the MongoDB. Okay, there's another kind of a database called the MongoDB, where you can store objects, not just tables, but you can store any XML objects into the MongoDB. That becomes an object oriented database because it stores objects. The model that is stored inside is objects, whereas here this is actually the relational database systems, where you can only do the tables. The same thing which we did previously using files. Now if you want to do it using database systems, what you will do now, create database called Jntuk Moocs. There I created a directory. Okay, so it's created now. Okay, now I can say use database called Jntuk Moocs. Okay, this I can, now the database is changed. Here I can say, instead of creating a file there, now I'll say create table called bank master. Okay, now you can say name, um, which is 10. Okay, and then balance, which is int. Okay, right. So this is how you can create a table here. The same thing that's created here. Okay, right. Now you can say insert into table. Now you can say insert into bank master. That's what you created. This is how, I think I actually made a spelling mistake. So I can say name, balance, values. Now you can give Ramya some 100, whatever you had given there. This is how you will actually use this database system now. There you have a C program and it is writing the bank master program. Here there is a table called the bank master. Okay. Now we are using relational database commands to actually now, okay, now this is inserted into it. Okay, now you can also say insert into now bank master. Okay, again you can insert, for example, Prabhakar. You can only insert rows. You can create tables, insert rows into this, and nothing else you can do. The file comes with that format here. So that is the data model here. Okay. Now you can say Krishna. Okay. Now you can say 200 here, whatever we did last time. Okay. Same thing. You can do whatever query is okay. Okay. Now if you want to retrieve whatever is there in this, you want to read the contents of this, you can say you want to select start from this is we'll read this more, so don't worry at this point of time. I'm only trying to create a understanding of how you would have worked with files and how we will work with with database systems. Okay, now you can see this gives Ramya has 100 balance, Krishna has 100 balance. So this is the only format in which you can create tables, and you can store your data only into this format here. Okay, and you can't do anything else. Okay, you can create tables, you can insert the rows into this into this relational database system. All this is provided by this program called the MySQL. This is what we are meaning by the database management system. It comes with this data model. This is basically called the relational model. This comes with this query language. You can access all the columns and tables and whatever information you want in the system using what you are seeing here as the query language. This is the language that is given on top of this data model. This is also called structured query language, SQL. Okay, that's the reason why this is also called MySQL. This is the language that is supported on top of this data model. Okay, now with this it should be clear. Now this MySQL program will support this data model. Then multiple programs are accessing this system. It ensures that there is consistency. When the power goes off, it makes sure logs are actually created, and then this table doesn't get corrupted. You will be able to retrieve the table back. So when you're developing banking applications, you no longer would like to develop the applications using the C program and files. You want to develop it using the database management system and a program on top of it. Okay. For example, we saw in the previous case, okay, the interface to the C program is, I'll not go into the complete details of this. We saw this here. So what we will do is we can use still a PHP program or any of the programs, but then here what we will do is okay, here instead of this we will now provide you with a sql.h, which will sort of give you all the interface instead of stdio.h, which is for the file system. Instead of this, the program will now include, if your C program has to interface with the database system, retrieve all the values of this will now include sql.h, and then write the program, create the SQL statements here. This is going to be completely different. That's what we're going to study as part of the course now. Okay, as part of the course now, what we are going to look at it is how to actually create these databases. What I've just shown as a database. Okay, what I've shown as a database, right? And then how to create these tables. What are the issues in table design, relational database design? For example, how do you create these tables? How do you actually come up with the attributes? Okay, will you create one big table, or you will split that into smaller tables? What are the implications of that? That is actually called the database design. Even before that, since you have to come up with the tables, the relations. For example, here you can see create a table bank master with to name and balance. Okay, You may also want to add address here. So first you have to do domain analysis. See what are the domains. In the domain, what are the entities and what are the attributes for this entity and what is the relationship between these different entities. This is called the domain analysis. It is also called entity relationship model. It's called the ER model. For example, there is a bank, there is a customer, there is an account. All these are the entities in the bank system. In the case of a academic system, there is a student, teacher, there is a courses. All these are different entities. So first thing is to get the entities in your domain, which is actually called the ER modeling, entity relationship model. The entities, after understanding the entities and the attributes, you need to convert the ER model into what is called the relational model. Each of this table here is called a relation. Okay, this is a first order relational model. We'll look into what the relational model means. In some sense, in a very simplistic sense, the relational model means this is tables. So we have a created table, the bank master and balance, whatever it is, and then right. So this you convert the ER model into what is called the relational model. The relations have to satisfy some properties. Each of these relation here should satisfy some properties for these relations to be good relations or good tables. Okay, so in some sense, all this comes under what is called the relational database design. How do we design these tables? Okay, uh, that's we are going to study next. First, we are going to study the entity relationship model. Next, we are going to study how the entity relationship model is converted into relational model. And once we convert the relations into relations, they should satisfy some properties, and that's what we call by the relational design. So we'll study the concepts of relational database design. Next, we are going to study how access a query the relational database system, the language part, what we have seen here, insert into SQL, select, create a table. All this is called the structured query language for working with the relational model. Okay, so that's what we are going to study next, the language for accessing and manipulating the tables, right? And then after that, we are going to study how we build these programs. For example, the C programs or PHP programs or whatever it is using these SQL constructs. That's where we are going to study how programs connect to the database, read tables information, the rows from the relational database, and how you manipulate and store things back. That's also the point where we're going to study how concurrent execution of the programs is made to a consistent setup in the database management system. That's also called transaction processing systems. How the programs which are manipulating the database will work with the underlying database system. That's why we're going to study the transaction processing systems as part of the database management systems. Okay, these are the 5 layers that we are going to study as part of the database management systems course. Okay, I think that should give you a complete picture and overview of what we are going to cover in this course and how we are going to go deep on part of that. Okay, there is a chat coming in here. There is look at this as giving you a higher level view. We'll get into varchar, and then I'm not actually dealing with these deeper aspects of how the tables are created and all that. I'm giving you a higher level difference between dealing with tables or database management system versus the operating system files. That's what I'm trying to teach you first. If you actually write programs using files, operating system files, that is not good enough for business applications. and you need the database management systems. Okay, I'll ask this question and see if anybody can. What is the most leaving fault tolerance and consistency part? Why do we still need, let us say we are not worried about those two aspects, why do we still need database management system? One very big reason why we will be needing database management systems. Can some student answer this question for me? What is the biggest plus point, or what is the biggest important reason why we need database management systems? I'm looking in the chat, see if somebody can answer this question for me. Last time, many of you are saying security. Is security the reason? Files also have security. Files can be encrypted. Okay. What is one big thing that files don't have, which database management systems have? Take the management part of it. Management system. Data systems have. The management part, let us say, includes fault tolerance, and they're saying to use them in business applications. So what is it? What is the big deal? I'm using different approaches to see at what level I'm able to get the students into understand and then respond back to me. Okay. I said leave fault tolerant consistency out, even to process queries. No, I guess that's part of the transaction processing, and then that's anyway part of the consistency and all that. I'm still waiting. Pragati Engineering College has one response. Jntuk B2 has one response. Independence, consistency, concurrent access, integrity. You're just repeating all the stuff that I had actually told, which you should exclude. Okay. What is the biggest thing? Biggest thing in the database management systems is the data model. Okay. They come with a data model. Okay. They come with a data model. What is the data model in MySQL? All these tables. They come with this model of storing the information, and it is where we were actually talking in the previous class on what are the problems with the data model. Okay. Now in this class we'll predominantly look at only relational database systems, where the relation is nothing but a table. Okay. What people have found is a large number of common business applications have this model called the table. Okay. Common lot of applications. For example, look at students' marks. Again, their table. Okay, so many common business applications can just be represented in this table form. So that's the reason why relational database model became the de facto database model, and that's where you see Oracle, so many database systems initially to start with. The storage for the data, the only data model that is supported for a very long time in database systems is the relational database model. That's also the reason why these are called RDBMS, relational database management systems. Okay. If you go back to my first class, I told you some examples where storing everything as a table will be clumsy or have a relational database management system. You may want to have a another kind of a system that gives a different data model. For example, if you look at MongoDB, recent advances in database systems, if you look at MongoDB, it provides object-oriented database systems. In some sense, the model inside is objects, okay, right? And if you actually go to another modern database system called Cassandra, it is a key value pair store, large distributed key value pair store, okay? So what we see as a predominant business application model, data model that is useful predominantly in the business applications, that is what we mean by the relational database management systems, okay, also called the RDBMS, okay, right? And that's what we're going to study in this course. Towards the end, I will also introduce you the other data models and emerging NoSQL databases. I'll get distributed database management systems don't want to be relational database management systems. They want to be something else. We will see that particular case, the case for that, as we go to the towards the later part of the lectures, almost towards the end. But what you should understand is there is a data model inherent in database management systems. They come with a data model, and the data model could be a big plus point or it be a big negative point. For example, if you're not able to store the data as tables, then you may not be able to use the relational database management systems. Okay, I think I'll stop here. Okay, and I'll few questions. If I let me see if I can go to some colleges. I'll just go to the okay. I'll spend some time interacting with the students. Okay. Okay. I want to catch one of the students here. He is the first student. Is the thing? Whom am I going to get here? That blue shirt person. Can I just get the blue shirt in the second row? Second row blue. Can you stand up? Blue shirt who was looking back, not trying to stand up. The blue check shirt who is keeping his hand on the nose. Yes. Yeah. Why is it so difficult to make you stand up? What's your name? Huh? What's your name?
Deepak, sir.
Deepak, how are you doing?
Good, sir.
Good, okay. So, if I have a few million tweets, have you looked at Twitter?
Yes, sir.
So, I have few million tweets. Will I be able to store them in a table format, relational table format?
Yes, sir.
How will I store?
In forms of rows and columns.
Rows and columns. So what are the different columns there? Column will be? What are the different columns? Column going to be? Tweet ID and tweet, whatever is the character string of the tweet, right? They're going to be two columns.
Yes,
Am
sir.
I right?
Yes, sir.
Huh?
Yes, sir.
Then, yeah, so what is the kind of processing that you can do with that kind of a thing? Can you thought it? Is that a good way of storing the tweets?
No, sir.
Why?
Since there are more number of items, you cannot store them in tables.
Why? 1 million means I can't store 1 million?
It will be difficult to locate them, sir.
See, I'll give you a small assignment, okay?
Yes, sir.
Huh? See,
Yes, sir.
what you have to do for me is write a small C program. Okay? What it does is
Yes, sir.
it opens the Twitter API. Okay?
Yes. Yes, sir.
Reads the tweets from the Twitter API.
Yes, sir.
Okay? And stores them in a
Yes, sir.
file. Okay? You're not going to deal
Okay.
with
Okay, sir.
databases now. All that you're going to do as first assignment is you will open a Twitter API, read all the incoming tweets, live tweets that are coming in, and will store them in a file. Okay.
Okay, sir. Okay, sir.
At some point, your program is going to fail because there won't be any space. Okay. I
Okay,
want you to do
okay,
that
sir.
and see how many tweets
Okay,
you are
sir.
able to really store on the file. Have you got the assignment?
Okay, sir. Okay, sir.
Yeah. Okay. Now do this assignment, small assignment. This will exercise for you to store things in a file. Tweet ID and the tweet this thing. Okay. Um,
Yes, sir.
I'll also tell you. I'll interact with you further and a couple of your other students there as I go forward to see if you've been able to do this exercise. Okay.
Yes, sir. Yes, sir.
Okay. This will be very
Yes.
interesting. As we go along, we are going to actually give you more different kinds of things as we go along on this assignment part. Okay. This is to start with a very simple
Yes.
assignment. Okay. Right.
Yes, sir. Okay, sir.
Yeah. So I'll.
Okay.
Your name is Deepak, right?
Deepak, sir.
Deepak. I'm going to come back to you, Deepak. Okay.
Yes. Yes, sir.
Okay. You're avoiding my eye contact, so I'll come back to you more often. Okay.
Yes, sir.
Okay. Right. Yeah. Okay. Thank you. Let me go to another college. Uh, let me go to my one other college, which is the other colleges that Chakravarti. I said I'll reach out to some colleges today, right? Is it 3C college?
Yes, sir.
Is the 3C college? Which is this 3C college? What is this college? What is the college name?
DMS switch.
Uh-huh. Which college is this?
SVH, sir.
SVH. What does SVH stand for?
Sri Venkateswara Hindu College.
See, Venkateshwara Hindu College. I'm seeing one girl at the back. Not much, uh, straight at the back. Can I just get her? The one behind, yeah, that last girl with the specs. Now she has put her, this thing, face to just see me. Okay. Are you watching, Ma? The one right at the back with specs. Can you stand up? The one right at the back. Right at the back. Stand up.
Supriya, sir.
Yes, excellent. What's your name?
Yes, sir.
Language you have written programs.
C language.
C language, right? Here is an assignment for you. I want you to actually send this assignment to my mail ID. Okay. Right?
Sir.
You have to write. I've shown you a C program today. Have I shown you a C program where I actually written the name of the customer and the balance? I've written that, right? Right? I want you to put I've used an append for the file. I want you to tell me what happens if you actually put a W there, write mode. Open the file in a write mode and you run the program multiple times. What happens? I want you to send that program back to me. Can you do that? Have you understood the question?
No, sir.
Have you understood that question? No, you've not understood the question. See, look at this program here, what I had actually shown you. Are you able to see the terminal?
Yes,
Are
sir.
you able to see the terminal? Yes. Okay. What happened to my shell? Yeah, this I think got closed. Okay, I've written this bank master program, right? You were actually seeing this program today, right?
Yes, sir.
This is A means what here? A means what? This file is opened in A mode. What does this A mean here? Append. This is an append mode. Append means whatever you are writing, it will write at the end. If the file is existing, it will add the writes at the end of the file. Okay?
Yes, sir.
Instead of A, I want you to run this program with a W mode, not A mode. W mode. Okay? Clear?
Over.
What will be W mode? It will be write mode. So you have not written programs using C and files. I think not.
Over.
That's the reason why. Huh? Are you understanding Ma now the question? Supriya,
Sir.
are you understanding my question? You have to write a C program
Sir.
with the W mode, write mode, not append mode, and tell me what happens if you run that program multiple number of times. Okay? I'm not just
Yes.
teaching, I'm not just wasting my time. I want to find out that you are also working hard. You are running this program and telling me, okay? Sitting at the back and avoiding me doesn't help. I'm going to come back to you. Okay? Right? Okay? I'll remember your name and I'll going to come back to you. Okay? Right?
Okay, sir. Yes, sir.
You didn't ask my email ID. So you're not planning to send anything back to me. Yes or no? Anybody in this class
Yes, sir.
will be able to do this, what I was telling? What will happen if there is a write mode? Can somebody tell me what would have happened? Yeah, I think there is one student who is picking that. Who can tell that?
Overwrite
If
mode.
it is right, over, what would have happened then?
Will overwrite the file.
File. So basically, some of the data will be lost. Okay, right? Multiple times, if you do that, will you lose some data or not? What are, how does that stdio io.h will work? What are the different driver programs that will be involved in that?
It is needed for printf and scanf statement.
No, but that's basically a high level you are telling me. What would have happened? What does the, how does the scanf will work? There is an FPTR, right? File pointer. Each time you're seeing this program here, how does this program will work now? For example, this fopen, what does this statement does for you?
Will direct to that bank master file.
How does it direct it to the bank master file? Can you be little more specific about what do you mean by direct? I just given a name here and a mode here. I said fopen. There's a file pointer here. What does the program does now? How does it work? How does the compiler will manage this fptr?
Fi- fopen returns a value to file pointer.
Where is this file pointer? What is this? Is this a variable? See, this char name is basically a variable. Name is a variable. It will have a storage 50 character storage in the program address space. Okay, what does this fptr will have?
It is a file pointer.
What will this?
It indicates another file.
So is it a variable?
Yes, sir.
What
It's a
is it?
variable of type file.
A variable type file.
Yes, sir.
How does it then go and get the data from the disk if it is just a variable? Are you seeing the link? Now you tell me, is it a variable, or what does that address space will look like in the program memory, in the address space? It is not that simple. Don't take things easily, okay? The file pointer is actually having a pointer to the address space, disk address space. This is actually a driver. There's a driver program involved in this. So it gives the disk block the address space, and then there is basically a buffer there. File pointer points to a buffer that is reading the data from the disk to the main memory. Okay, it is transferring. Now each time the pointer increments and reads some value from the buffer, it comes to the end. The driver goes and fills the next block from the disk. So there is so much involved in how the file is read. Okay, so it is not a simple one of how this file pointer itself is handled will cause so many issues for you. For example, what happens if the power goes off? The power goes off, the file pointer information is lost for you. Okay, what has been written on the file or what is stored on the main memory is not available for you. Okay, that's what causes the inconsistency for the file. I'll explain this to you a little more. Okay, imagine to give you a simple understanding, this file pointer is nothing but a pointer to the first record in the file. Okay,
Sir.
some bytes file, first few bytes in the file. Okay, now when the program is reading, this is stored in the buffer in the main program. That means some contents are transferred from the disk to the main memory. Okay, where is the file? The file is in the, where is the file?
Buffer.
File is in the hard disk. Okay, file is in the hard disk. Okay, and the contents of this hard disk are being read and moved to the main memory.
Buffer.
Okay, buffer, there's a driver program involved in that. So the buffer is where the data got transferred. Now when you write, the file is written, it is a buffer that is first written and then lazily written back onto the disk. Okay, the driver then writes this data back onto the disk. Okay, now if the power goes off, this buffer will be lost because that's a volatile memory. Okay, is that clear now? So there are several layers involved here. So what can happen, you will not have control because the one part of the data is in the hard disk. What's your name?
Jagadeep, sir.
Jagdeep. This is what causes so many problems in handling the data. That's why you need database management systems. because this handling from the disk to the main memory is lot more complicated than what you are actually understanding. Something written on the volatile memory, from volatile memory to the permanent storage, that's the disk storage, is a very involved process, and files don't do this, handle this at all, whereas database management systems will handle this problem very carefully. That's the reason why you get fault tolerance and all those things when you actually make this into a file system, into a database management system. The other most important thing is how fast, if there are millions of rows there, how fast this file is read is also important. For example, imagine there are 1 billion customers and you go to the ATM and try to retrieve your bank balance. It takes 15 minutes. Is that okay for you?
No, sir.
So the speed at which these are retrieved also becomes extremely important. Okay, we're going to see all of this. That's why it's a very interesting and challenging one to look at deeper. So look at the depth part of it. Just don't look at the surface level. Okay, as you go deeper, you start seeing that not just the main memory. There is an L2 cache. There are several layers of cache. So where the data is resident at a given point of time, and what is modified, what the modified part is written back onto the disk causes so many issues. Okay, the architecture, when you go deeper into it, you start seeing there are several layers of programs that actually handle this data. Okay, we'll come back to this. So simple thing is give it in a write mode, and you are saying overwrite mode is a very simple answer. That happens, correct, you are correct. But the reason why I asked this question is you should go a little deeper and start looking at how operating system handles files. Okay, right? That's the reason why I'm actually asking that question. Okay, good. So I'll just, that's fine. I'll come back to you later. Okay. There is one more college which I wanted to see today. Let me, Chakravarti, which is the other college? A8, is it? Yes. Which is this college? They're all hiding themselves behind the screen. Which is this college? Who is the teacher in this college? Everybody is hiding themselves behind the screens. I can't see anyone here. Everybody is behind a screen. Can somebody stand up here? Which college is this?
Vasavi Engineering College, sir.
Vasavi Engineering College. Can I no, have that last I'm having a problem here. Hi, are you the teacher? What's your name? Good afternoon. What's your
Manasa,
name?
sir.
Are you the
Manasa,
teacher?
Manasa, sir.
Manasa is the teacher. So can you get one student from here? I'm not able to see any of the, all of the students are hiding behind the screens. Are they listening to me or are they sleeping?
No, sir, they are listening to you. They are listening, sir.
Give the this thing to one of the students. I want one of give the mic to one of your best favorite student.
Yes, sir.
Good afternoon, sir.
You are the best student, best favorite student.
Good afternoon, sir.
Good afternoon. What's your name?
Rajesh.
What's your name?
Rajesh, sir.
Huh?
Rajesh, sir. Rajesh. Rajesh, sir.
Nagesh.
Rajesh sir. Yes sir.
See, there is some issue here. I'll come back next next class. I'll come back to you. Can you just set right your mic for me? Next class, I'm going to come back to you
Rajesh,
first.
Yeah, sure,
Are you
sir.
able to hear
Sure,
me?
I'll make the arrangements. Yes, sir.
Yeah, looks like there is a problem with the no with uh, the mic setting. Okay. I'll come back next class, and then I'm able to see you, but I think there is some problem with the mic. Okay. Fine. I'll come back next class. Okay. Fine. Okay. Yeah. Fine. Yeah. Stop here.